Hello everyone and welcome back to the series. In the last video we looked at how we could use the breadboard and the Arduino Uno to make an LED light up, like so. In this video we will be looking at how we can control the LED using code. So without further ado, let's get started. Okay, so if you haven't already, you need to download the Arduino IDE. So you can do so from the official website and choose the platform that the OS you are using and proceed to install it. So in my case, I have already installed the IDE, it's already open. So this is already done. However, if you don't have it, you should install it because the rest of the video and other videos in the series will be using this Arduino IDE. Another thing you should install if you're using the cheap Chinese clones of the Arduino Uno board is this CH341SER zip file, which contains all the relevant drivers for the CH340G. So the CH340G is a very common USB to serial converter that a lot of these clones use, and it will not be instantly recognized on your computer unless you install this driver. So I'm going to show you how to do it for Windows. For Windows, this is going to be quite simple. We simply just extract the files, and then we see over here we find this setup application, and clicking on it will open this window. I don't know if this shows on the screen recording, but I will put a screenshot up if it doesn't. We click yes, and then we will see this little dialog or the wizard, and we can click install. So when we plug in our board, we click install, and if everything is correct, so in this case my board is already plugged in, so I'm just going to click install, and we should see that it says success, which means that the driver has been successfully installed. So a great way to check if everything working correctly is to go into device manager and to look under our ports, and we should see this USB 0 CH340 device listed under the ports, and that means everything is good. So if that doesn't show up, or if it's it says unidentified driver or whatever, then you can simply try to install this again, and it should work. Okay, so now that we've covered the basic setup of the basic download and setup of our drivers, let's go into the Arduino IDE. So opening the Arduino IDE, you will be greeted with this screen. So this in this video, I'll go through the basic the basic functionality of the IDE. So over here you have this toolbar which has all these various submenus. So over here, file, these are pretty self-explanatory. The sketchbook is a repository of all the example codes that you can use to the sketchbook is the repository of all your code that you have written. So all your your projects that have been saved into the Arduino root file will all appear here. The examples is where you find all the repositories of example code that have been created and are included with your library. So over here we see the built-in examples, we see these basic ones, digital, and so on and so forth. And of course we also have examples from libraries that have been installed from third parties such as GitHub or the the library manager, and these will also show up here. So take some time to explore this. If you haven't installed many libraries yet, you shouldn't see too many, but there will still be some, and as you install more libraries, this thing just gets longer and longer. Okay, so that's done. We have these are the functions: close, save, page setup, print, preferences. So when we go into preferences, we can see our sketchbook location, which, as mentioned, this is where all your sketches are saved, which will show up under your sketchbook here. So this is your sketchbook location. You have your editor language, which we'll set as system default, and font size. So if your font size is starting off as pretty small, then you can start to increase it. And this is interface scale. I don't know what it does. Leave it as automatic. Theme, default theme, and of course we have show verbose output. This is how much information will be displayed on this terminal over here when you upload code. So in this case, I've set mine to compilation. You can also set this to upload if you want to debug your uploading to the board, but I feel that this isn't very necessary. And once again, compiler warnings, setting it at none will mean that it won't throw any warnings, which means that your code will compile more easily, but it also means that you may miss out on certain errors that are thrown. So setting this to default and more and all would just mean that the compiler will be extra picky, and it will really just stop the compilation and tell you the warning whenever something goes wrong. So this is useful if you have a code that you want to really debug in depth. All of these other parameters are really just for your own convenience. The next thing is this additional boards manager URL. So you can add more boards into the Arduino IDE than the ones that are already supported out of the box, and you do so by editing this text file, I think, or this field, and you put in the links to all of these additional boards. So over here I have a lot of boards that I've added because I really have experimented with many boards. For you, it most likely will be empty, but as you go along you may want to add more boards, and this is where you do it. So the rest of it, this is just where your preferences can be edited in a text file, and that's about it. So that settles this file tab. Edit tab, we have pretty much just editing tools. I've never really used this tab. I think the most interesting one would just be the copy as HTML. So if you write some code and you want to preserve the format of perhaps the fonts and the colors of the Arduino IDE for visual, to make it more aesthetic, then you can just copy it as HTML, and you can paste it in a HTML viewer, and then copy and paste that into your forum or your blog or wherever you want to place it. And that's about it. I don't think the rest of this is really useful. So it's under Sketch, we have our verify and compile, upload, uploading programmer, and the other stuff. So verify/compile means to compile your sketch. So the Arduino IDE is built upon a mixture of C++ and C hash. It's their own unique blend of the C++ XX language, and they will compile they will convert your whatever code you write here. So for instance, all this code you write, it will be sort of translated into machine code and then uploaded to your board. So that's what compilation does. It basically just creates this temporary file, it checks that everything is correct, and then it will convert it into machine code. So that's what compilation does. Uploading takes it one step further. So after checking and converting into machine code, it will then send the data to your board, and that's how you get your code onto your board and run code on your board. This upload using programmer is a more complicated way of uploading, which means that you don't use the built-in USB to serial converter, which as I mentioned was the CH340G or CH340C. Instead, you will use a third-party board to program the Arduino. That's a bit more complex and not really in the scope of this series. And the rest of this is just for your convenience, like to include libraries and add files. So include library means that you basically copy over code that someone else has written already and input it into your code. So a library is like sort of like a package, like an extension pack that you can use to augment your code without having to write out things by yourself, because you can piggyback off some other people's work and use their functionality. So typically you would put include statements at the top of your code. That's not really in the scope of this video yet, but the idea is that if I say would want to import this TFT library, now just click on this and it would put this include command and then TFT. So that's that. Another thing about the libraries is that from here you can add a zip library. So if you download a library from GitHub as a zip, you can add it, and you can also open the library manager. So this is a built-in sort of like a marketplace where you can find libraries that other people have written and you can download them. So as you can see, there are a bunch of libraries here that I've not downloaded because I don't need them, but you can search for the library that you want, say ESP, I don't know, ESP or something, and then you can find whatever library you want and then you can download it. So that's pretty cool. And the next submenu will be tools. So I don't really use these tools very much because So don't really use this auto format, archive, sketch, fix, and blah blah blah. I only use perhaps the managed libraries as we've seen earlier, and of course serial monitor. So the serial monitor is there we go. The serial monitor is sort of like a interface or like a communication portal that allows you to communicate with your board. So we will go over this in a future video, but essentially when you send data from your board to your computer, it ends up in a serial monitor. So that's where you can look at the data. Serial plotter does the same thing, but instead of printing it as a string, it actually will map the value in a graph. It would chart it as a graph. That's serial monitor. Of course, we have some other stuff which I don't really use, and the most important is this board. So this allows you to change the hardware or the settings of the hardware that you're going to use. So in this case, we are using the Arduino AVR, Arduino Uno, but we can use other boards. So if let's say I were to use an Arduino Nano, I would choose this. If I were to use another board, let's say I downloaded the ESP32 libraries, ESP32 board manager, so download the ESP32 packages from the board manager, I can then do it from here. So choose ESP board I'm using, and so on and so forth. This COM port setting is to set the port which your Arduino or microcontroller is connected to. As we have seen in the device manager, we have connected our Arduino to the computer, and it shows up as a USB serial CH340 COM6. So when we upload code, we should use COM6 because that's where our microcontroller is connected to. So this is also pretty useful. If you have multiple microcontrollers connected, you can sort of like toggle between the 2 or 3 and then choose the board that you want to upload code to. The rest of this is pretty advanced. Programmer is basically what programmer going to use. In most cases, is just leave it as nothing because we are using the inbuilt serial USB to serial converter. And burn bootloader is when you are building your own Arduino Uno. So maybe another day we'll get into that, but that's out of the scope of this video. So help is basically those like a help manual for most programs, and that pretty much sums up the toolbar. So over here we have some commands, and actually these commands are duplicates of those in the toolbar. So over here we have verify, that's the same as this compile, verify/compile. We have I think verify is only to verify, verify means only to verify, I have no idea, but I believe it also compiles. So verify means verify and compile. Upload is as the same thing over here, upload. This is to create a new sketch, this is to open, and this is to save. So very simple things. We'll be using verify and upload a lot, so just kind of remember that the verify is the tick and upload is the arrow. You can also use the keyboard shortcuts, Control-R for verify and Control-U for upload. I find those pretty useful, but once again, you can easily find these tools here as well. Okay, so now that we've looked at the basics of the Arduino IDE, let's start writing some code. So the first thing we'll do, let me delete this, no idea why it's here, is to write a code that will tell us. Okay, so let's go back from let's before we start, let's actually recap, or let's remind ourselves of what we want to achieve. So we want to blink. The goal is to blink an LED. So essentially, what does that mean? That means we turn LED on for, say, X amount of seconds or for a set time, and then turn it off. And then we repeat this forever. So that's the goal of our code, and with that in mind, we can start. So as you have seen earlier, we need to start with a pin mode command. So what the pin mode command does is that it will take 2 arguments. So arguments are things you supply to the function. So pin mode is a function because we as a command that we're calling, and we're going to put in the first argument, or the first parameter we're passing to pin mode is going to be the pin number. So we're going to choose pin 10. If you recall that in the previous video we did a breakdown of the Arduino Pinout. We have various digital pins. We have pins 2 to 13 are digital pins, and we can use any of them. So in this case, I'm using pin 10 because I think 10 is a really nice number, but you can use any one you want. So 10, and the second argument we put in is basically just either one of 3 options. We can have input. Okay, I'm just going to write it at the side here. So input pull up, and output. So what input and input pull up is, well, you can see that they both have the word input. So input means that we're going to input a value. So we're going to read some form of sensor, like a button, like a switch, or some form of digital sensor. Input pull-up is something like input, just that there's an internal pull-up resistor. We will cover this in the future videos, but not in this one. And output is what we're going to use today, which is we're going to output a voltage, a value to the pin. So basically, we're going to say it is going to be high or it's going to be low. So that's what those are the three options that we can put in. Okay, so we set pin 10 to output, and we do it in this thing called the void setup. So void setup is also like pin mode. You see, it has this two curved brackets, or sorry, two normal brackets. This means that this kind of is a telltale sign that you're looking at a function over here. So setup is a function that it's called whenever the board is turned on, or whenever you plug it in. So it occurs only once. So as see this comment says, it says put out your setup code here to run once, and the things that are in between the curly braces, the code that you write in between these two curly braces, this is what is run on setup. And once that is run, it runs once and it never runs again. And over here we see void loop. So void loop is also a function, and it will run repeatedly. So whatever you put in this over here, put in the curly braces over here, will just run forever and ever, just keep looping back and repeating over and over again. So this comment also sums it up perfectly. Alright, so you might be wondering, what is void? Because, you know, surely pin mode was just, you know, this we didn't really put this void in front of pin mode, right? The thing is, void is like a type of, it's a type, something like a data type. So what it does is it tells the Arduino IDE that this is a void type of function. So it's not going to return anything. It's not going to output anything. So once the function is done, it's just going to end. There's no value, or there's no result from the function. It's just going to do whatever is necessary, or whatever it contains, and then it's just going to leave, and there's nothing it's going to, you know, it's not going to give any results. So that's what void is. There are other data types. We will go through them in a future video, but just, you know, just don't be too put off by this void setup. It's just saying that setup occurs and there's no result from setup. It just does whatever is in setup and it leaves. Okay, so now that we've settled this, we've explained what all these things are, let's move on with our code, and let's basically go back to our goal, which is to blink an LED. To do so, we turn it on for some set time and then turn it off. Okay, so we're going to say digital write, which means we're going to write a value. So we're going to write it, and it's going to be digital because we have chosen a digital pin, which means that we're going to either set it to 1 or 0, high or low. So we're going to write, the first argument is like pin mode, is going to be the pin number. So we need to keep this constant because we've set pin 10 as an output pin, so we should quite naturally do something with pin 10. So 10, and then we're going to say high, and there really is only two options. There really are only two options with this. It's either high or low. Because this is a digital pin, it only has two states. It can either be high or low, or actually it can also be in this unset state, which is also known as floating, but let's just let's ignore that for now. So we write pin 10 to high. So let's just put a comment says turns pin 10 to high. And then we're going to use the inbuilt delay function. So delay function means that we wait and do nothing for the amount of seconds. So this is going to be milliseconds. So if I put delay 1000, that means I'm saying I'm going to wait and do nothing for 1000 milliseconds, which is 1 second. And that's exactly what we want to do, because we want to turn it on for a set time. So we're going to turn pin 10 on, we're going to wait for 1 second, and then we're going to turn it off. So that's exactly what we're going to do. So turns pin 10 to low. Okay, and we have to delay 1 second again. So you might ask, why do we need to delay 1 second again? Well, that's because of the way loop works. So as I've said, loop will execute over and over again. So if digital write, if we say we write it to high, we wait, and then we write to low, if we don't put this delay, what happens is it immediately goes back to the top, so it's going to write to high again. So what you get is the LED turns on, it waits for 1 second, it turns off, but then immediately turns on again. So this will basically mean that the LED never really turns off, because it turns off for like a split second and turns on again. So that's not what we want. We want it to turn on and then turn off for some time and then turn on for some time again. So that's why we put this delay over here. Okay, so this is a really simple sketch, and let's upload it and see what happens. So we're going to go into tools, we're going to check that we have the correct board selected. In this case, we have Arduino Uno, that is correct. We're going to check our port. This is port COM6, which we can confirm that it is indeed the one we have connected our Arduino Uno to, and then we can simply hit our upload button. So at this point, it will prompt us to save our code. I don't really care about this code because it's so simple. I'm not going to save it, but if you're working on a much more complicated project, you should really save your code from time to time to avoid losing everything if your computer hangs or if something goes wrong, you know. Just need to be really safe about, really careful about that. So I'm just going to hit escape because I don't really care about saving this code, and we'll see over here that this bar starts to grow. So this thing says, this bar shows how many percent of the compilation is done. Well, for my computer's case, in my computer's case, the compiler is really slow because my computer is so bloated with various libraries that it takes ages to compile and upload. But let's just say that yours might be a lot faster than mine. So I will cut the video here and we will come back to the final Arduino board. Okay, we have come back to the board and it is where we've left it off. The last video we did a simple LED setup, and that's exactly what's happening. The LED is just being left on. So we are going to edit and modify this breadboard to accomplish our latest goal, which, as mentioned earlier, was to blink an LED, turn it on for a period of time, and then turn it off for a period of time. So let's change this. So the first thing we have to do is we have to use pin 10, because in the earlier in earlier part of the video I showed how we set pin 10 to be the pin that we want to use. So we're going to have to change the connection from, say, having it at this 5 volts over here. We're going to put it away, and we're going to put a jumper wire into the same column as the resistor. Once again, going back to the very first video, we talked about how the columns on a breadboard are all connected together. So that's exactly what we're doing here. We're putting the pin onto the same column as the resistor. So therefore, this is connected to this. And we're going to put this into pin 10. So that's 8, 9, 10. Okay, so we see that this is blinking on and off, and it stays on for 1 second and then goes off for 1 second and comes back on again, and this repeats forever. So that's exactly what we wanted. So our code is working correctly. So that concludes this video. I hope you learned something, and I'll see you next time.